This is episode 38 of our Chinmaya Algebra series, and for this video, we are given quite a couple of variables. We have here x, y, and z, as well as p, q, and r. We are given that x cubed plus y cubed plus z cubed equals 3 times the sum of 1 and x, y, z. Meanwhile, we are given the relationship between p, q, and r in terms of x, y, and z. The goal is to find the value of p cubed plus q cubed plus 3 cubed or r cubed minus 3pqr. For this video, our main solution would focus on one identity, and that identity is that the sum of x cubed, y cubed, and z cubed less thrice their product can be factored as x plus y plus z times x squared plus y squared plus z squared minus xy minus yz minus xz. This is one important factoring formula that I think I have mentioned in passing in our previous video. I think that would be around somewhere around somewhere around the first 10 episodes. I'll put a link of the related video somewhere in this description. But anyway, if we go back to this one, we can simplify this further by writing the sum of the squares as x plus y plus z quantity squared minus 2 times the product of xy plus yz plus xz. Because we have another xy, yz, and xz here, actually this becomes 3. So this expression is equivalent to this expression, which means that if we look at the first given equation, that's x cubed plus y cubed plus z cubed equals 3 plus 3xyz, we can put the 3xyz on the left side to make it x cubed plus y cubed plus z cubed minus 3xyz equals 3. Now if we use this formula, we have here x plus y plus z times x plus y plus z squared minus 3 times xy plus yz plus xz equals 3. Let's just simplify our writings by letting this variable be m and this be n, such that this expression becomes m times m squared minus 3n is equal to 3. Let's save this for later. Next, the expression we're looking at or we're looking for is p cubed plus q cubed plus r cubed minus 3pqr resembles very much this given formula here, which means that we can write p cubed plus q cubed plus r cubed as, minus 3pqr as p plus q plus r times p plus q plus r squared minus 3 times pq plus qr plus pr. So again, this is the formula, the same formula we use for the first equation. So the goal now for the rest of the steps is to write this, or at least express this in terms of this one. Because they have, or they look very similar, perhaps they have a connection somehow. So we'll try to do that. And to do that, we will have to make use of the given values for, or the given expressions for p, q, and r. We have p is equal to x plus y minus z. We have q as y plus z minus x. And lastly, we have r as x plus sorry, x plus z minus y. Note that if we add the three of them, the left side becomes p plus q plus r is equal to, note that we will have here two x's, 1x, 2x, so this becomes 2x. Similarly, we have two y's here, so we have 2y and then 2z as well. And then we have here the sum of x plus y plus z, the negative ones. If we simplify this, we get p plus q plus r is equal to x plus y plus z, which means that this thing here is just equal to x plus y plus z, which based on our assumption earlier, we let that variable be m. So this one is actually equal to m. So this is m squared minus 3 times pq plus qr plus pr. So right now, we still have no idea what this expression is. So to do this, we can multiply p and q. Get pq is equal to x plus y minus z times y plus z minus x. This looks too tedious, too long for me because we are multiplying a trinomial by another trinomial. So I'd like to suggest an alternative step for this one. Instead of multiplying a trinomial, I suggest that we write this p as x plus y plus z minus 2z, which based on our um, assumption, x plus y plus z is m. So we have p here as m minus 2z. We do the same for q. We have m minus 2x. And for r, we have m minus 2y. Which means that, I'll just draw a border here, pq is equal to m minus 2z and q is m minus 2x. If we multiply them, we get m squared minus 2 times x plus z times m plus 4xz. I just factored it out, but this is just a product of using the FOIL method for multiplication. Here, and then the inner terms, what did I do? Okay, you get the point. Anyway, we go back and do the same for PR. PR is equal to m minus 2z times m minus 2y, which is m squared minus 2 times y plus z m plus 4yz. We do the same to get the expression for QR. So in the next page, I'll just rewrite them. PQ is equal to m squared minus 2 times x plus z. Am I correct? Oh, sorry, x plus, yeah, x plus z. X plus z, m plus 4mz. Actually, it doesn't matter how we assign them because they are just symmetric anyway. So I'll just write all the pairs. M plus 4xy, and then we have here PR equals m squared minus 2 times y plus z m plus 4, oops, it should be x, let's be yz. And then we get the sum, pq plus qr plus pr is equal to, we add this 3m squared, we add this and factor out the 2m, minus 2m times x plus y, y plus z, and x plus y. Then plus, factor out the 4 here, xy plus yz plus xz. Let's rewrite this one. as 2 times x plus y plus z. So we have here 2m times x plus y plus z plus 4 times xy plus yz plus xz. Recall that x plus y plus z is m, while this one is n. So we get this expression as 3m squared minus 2m times m. Oops, sorry, there should be a times 2 here because there are two of them. So actually this coefficient should be 4. So we have here negative 4 times m plus 4n. We simplify this, we get 3m squared minus 4m squared plus 4n, or simply negative m squared plus 4n. So this product here, or this sum of products here, is equal to negative m squared plus 4n. It's quite a long one. So we go back to this one. So we have this one as being equal to negative m squared plus 4n. Therefore, the expression we're looking for is this thing here, which I will just rewrite in another page. I'll just copy this one for now and then put it on another page. So we have here this expression. It's getting messy, but I'll put it here. M times m squared minus 3 times negative m squared plus 4n. I'll just simplify this one. M times m squared plus 3m squared minus 12n. Simplify again. M times 4m squared minus 12n. Factor out the m. Oh, sorry, the 4. So we get here 4m times m squared minus 3n. Therefore, the expression we're looking for is equivalent to, so this expression here is equivalent to what we found earlier, which is 4m times m squared minus 3n. We're still not yet done because m and n are just made up expressions that we did to simplify the writings. But if we go back to our previous analysis, we have here m times m squared minus 3n equals 3. And the expression we had earlier is 4m times m squared minus 3n. This one is 3. Therefore, the entire expression is just equivalent to 4 times 3, or 12. Therefore, the answer we're looking for is 12. And that's our final answer. This is quite a long one. I actually found this problem quite hard, and so far the hardest that I have answered for this series. I'm not sure if there is an easier way to do this. I hope there is. If you figured out how to do it more conveniently than I did, please let me know in the comment section so I could learn too. So again, the most important step that we made here is to use this identity. I certainly hope you learned something from this video. And if you haven't subscribed yet, please consider doing so. Thank you for watching and see you on the next one. Bye-bye.